So now we're going to do some more graphing. So we're practicing the graphing that we've done before, and we're going to look at solving quadratics. To solve them, that means we're looking for the x-intercepts, or where the graph crosses the x-axis. That's always going to be a solution for a quadratic equation. Our first step is to rewrite the equation in standard form. So just remember that's like ax squared plus bx plus c equals 0. The equals 0 is really important because we want to know when does it equal 0 so that we are solving for the right piece. Graph the equation, so looking for our line of symmetries, doing our table pieces, and then locate the x-intercepts of the graph because, again, those are our solutions. So the first one is already in standard form. It's equal to 0. And then what we're going to end up doing is we're going to look at that axis of symmetry, which remember is the opposite of b divided by 2a. And that tells us where our graph is symmetrical about. So in this case, that's going to be negative times negative 2, or a positive 2, divided by 2 times 1, because if our a isn't written in, it's just a 1. So 2 over 2, or 1. That's our x value, because it's an x equals equation. So I'm just going to go ahead and I'm going to start my graph just here at 1. Actually, we could do it the other way, because I want my point 0. So if I kind of going in the middle, I'm going to put my point 1 in there. And then I'm going to substitute that 1 back into my equation. So 1 squared minus 2 times 1 minus 8. We were doing the graphing piece at the beginning of this unit, so a couple days ago. So that would be negative 9. And again, I want to get my table filled out first, because once my table is filled out, it's a lot easier to know where I have to draw my graph piece. And then I have a choice of 2 or 0. They both should be the same thing because they are symmetrical. 0 is a much easier number to use, so I'm going to go ahead and use 0. So it's 0 minus 8. So these should be at a negative 8. And then I'm going to put in my 2 pieces in my graph, the negative 1 and a 3. Again, you can use either one. It doesn't matter. I'm just going to go ahead and use the 3 on this one. So 3 squared minus 2 times 3 minus 8. And I'm choosing to use the 3 because I don't have to worry about negatives. 9 minus 6 minus 8. And so that ends up, I'm confusing myself here, ends up being negative 5. And I need to keep going until I get to zeros, or until somewhere where I've passed where that x, where I've crossed that x-axis. So I'm not done yet. And so then I have a choice between negative 2 and 4. So I'm going to go ahead and use the negative 2 just because I have more room to write down there. Negative 2 squared is going to be 4 minus 2 times negative 2. So far I have 4 plus 4 minus 8. And I get my 0 and my 0. And I don't really need to go beyond that because that's where I have my solutions. So graphing this, I know I need to get down to a negative 9. So I'm just going to choose to put my x-axis closer to the top. So that way when I'm graphing, it's a little bit easier. At 0, I go down negative 8. At positive 1, I'm at negative 9, and that's where I have my symmetrical piece for. And then negative 1 is negative 5. And that's also going to be the same as 2. And then at negative 2, it's 0. And at 4, it's 0. And I can kind of estimate where the rest of my graph will go. So on this one, my solutions are going to be x equals negative 2 and x equals 4. And it's because of this point, negative 2, 0, and 4, 0. Those are, again, considered the solutions to the graph. So we are just doing more of those pieces. If I look at B, I need to set this equal to 0 because this isn't equal to 0. And to do that, I'm going to add 6x to both sides. And then I want to put it where it is in standard form. So once I have it equal to 0, I'm good. I don't have to worry about the other parts of it. And now I can come up with my axis of symmetry. So x is equal to opposite of b over 2a, which in this case is negative 6 over 2 times negative 2. So negative 6 over negative 4, which would be 3 halves, or 1.5. So looking again at my table, I don't know how long it's going to take, so I'll just make some marks here. At 1.5, I'm going to find my y value, and then I'm going to look at 1 and 2. I'm not going to keep going up by the 0.5s because that's just going to be too difficult to kind of keep working with that. So I have negative 2 times 1.5 squared plus 6 times 1.5 plus 8. And I could just go ahead and type this into my calculator. And plus 6 times 1.5 plus 8. And I get 12.5. And then I'm going to go ahead and look at my next piece. I'm going to do either a 1 or a 2. Again, I don't want to keep going with the 0.5s. That's just telling me where it's symmetrical. So I'm going to use the 1. So we have a negative 2 times 1 squared plus 6 times 1 plus 8. So 1 squared is 1. Negative 2 plus 6 plus 8, which would be 12 and 12. Because once I know one, I know the other. My goal is to keep going until I get those down to 0. So I have a choice of 0 and 3 because I'm going down in one direction. So I'm just going to do the 0 because that would just give me my 8. That's my y-intercept. And not a lot of calculations on that one. And then we have negative 1 and 4. So we have negative 2 times negative 1 squared. Remember, that's still going to be a 1 times negative 2. Plus 6 times negative 1 plus 8. So I get negative 2 minus 6 plus 8, which equals 0. And if I needed more, I would just go ahead and get more spaces. Drawing in my x-axis kind of in the middle, I could do that for all of them. My y-axis, sorry. My x-axis, I need to be able to go up to that 12.5. So I'm just going to draw a little bit lower to the bottom and see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have to go a little bit lower. That wasn't high enough. Let's go down here. And then again, I'm going to go ahead and graph those. So negative 1 is at 0. At 0, I'm up 8. And then at 1, I'm at 12. 1, 2, 3, 4, 5, 6, 7. Oh, I think I'm off on my 8. 1, 2, 3, 4, 5, 6, 7, 8. Then 9, 10, 11, 12. And then I'm at 12. 1.5 would be at, so it's kind of in the middle there. And then I come back down with that symmetrical piece. Can draw it in. Even if I didn't go all the way down, I have a good idea of where that graph would go. And then my solutions. And again, they're on my graph. Will be negative 1, 0, and 4, 0. It's where they cross that x-axis. You're still doing the same thing, even if it talks about double roots. Don't worry about what that is. You're setting them equal to 0. Go ahead and solve those and then check the answers with the answer keys. And you can pause, work on those and check them. And then I'm going to just go through this last piece here. So if I'm having an equation, it's the same idea of what we've been using. Again, we're not doing our bookwork here. It's the same idea of what we've been using. I want to know when it touches the ground, which is the same as when it equals 0. And so I'm also, it's going to be able to tell me how long the ball is in the air because it's going to be until it touches the ground. So looking at this, I'm going to start with my axis of symmetry. So my x equals opposite of b, which is 47, divided by 2a, so 2 times negative 16. Divided by negative 32. And this tells me at 1.4 seconds. So that's going to tell me that halfway point. I'm not going to necessarily worry about that particular piece because it's really not asking me to do tons with that. It gives me a little bit of idea. I'm looking at my equation here, and I'm not sure what that is. I'll have to rewrite that for your problem. So we can go ahead and we can type that in, and we can figure out what the height of the ball would be at that point, just so that we can graph this information. And when we're graphing this one, since we're actually talking about a height of a ball, I don't care about the negative piece. We're just going to graph it here on this side here. So putting in 1.4 for t, so negative 16, 1.4 squared plus 47 times 1.4 plus 3. This is where sometimes the graphing calculators can be a little bit nicer to put those in, but with a regular calculator, you'll figure out what works for you to be able to put those in. And so this equals 37.4. I didn't need that parenthesis at the end. So 37.44. Again, that would be height of a ball at 1.4 seconds. And so I'm going to just kind of look at what happens at 2 seconds or what happens at 3 seconds, because I want to know, when does the ball hit the ground. I can look at the same idea on the other sides, but we're just going to pick seconds that I know. So at 2 seconds, also, if I know my axis of symmetry is there, it's got to come down pretty quickly, because when I type in 0, which is my y-intercept, it happens at 3 or has a height of 3. So I could graph that piece in right away. I know that at 3 seconds, and I have to go up to 3. Let's go 5, 10, 15, 20, 25, 30, 35. We don't have to go quite that high. And that's as tall as the ball's going to get. 2, 4, 6, 8, 10, 20, 22, 24, 26, 28, 30. Oh, I was so close. 32, 34. We're going to extend it. 32, 34, 36, 38. So we're getting pretty close. At 1.4 seconds, we are going to be up here at that 37.44. But I know that I'm starting at 3, because if I plug 0 into my equation, I get 0 plus 0 plus 3. So that gives me my y-intercept, which means that coming on the way down, it shouldn't take me too long either. Negative 16 times 3 squared plus 47 times 3 plus 3. So just putting in, oh, I'm sorry, it was a 2. Putting this into my calculator then. So negative 16 times 4 plus 47 times 2 plus 3. This equals 33. And then I can look at what happens at 3 seconds. Negative 16 times 3 squared plus 47 times 3 plus 3. So negative 16 times 9 plus 47 times 3. This equals 0. So at 3 seconds, I'm back here on the ground. At 2 seconds, I was up at 33. So it goes up really high and comes back down and touches the ground. Sometimes on these problems, we won't get it to equal 0. It'll be really close, and the next number we know it's going to be beyond, and we would just say it's between two numbers. We'll come up with a way a little bit later. The y-intercept is going to be that 3, and that y-intercept is where the ball starts. So they are hitting that ball at 3, whatever, I believe heights in feet, so at 3 feet off the ground. So if you think about it, that's probably more just like right where you would be hitting up with a bat. And so the ball is not from the ground. It's not like it's a golf ball that we're hitting up into the air. And that's that real life context. So you have a couple more that you're graphing, and then you're working on that homework piece. And in the homework, you're going to practice with some of the factoring as well. So it's not, if you have questions, stop in at office hours.